Welcome to this video, dear learners. In this video we'll be looking at force. This is an important topic in physics. So please, if you're watching this video for the first time, click the subscribe button, like and share the video. Okay, so force is defined as a pull or a push that is exerted on an object. Okay, all objects around us, including us human beings, we are affected by what? By force. Okay, so a force is a pull or a push exerted on an object. So let's consider this person here pushing this wheelbarrow. Okay, so this person is pushing a wheelbarrow. Okay, it's pushing a wheelbarrow. Okay, so now as the person pushes the wheelbarrow in this direction, okay, so this person is applying a force. Okay, the person will apply a force, okay, in this direction. Okay, so you find that this is the object. Okay, the object that the force is being applied on. Okay, so this is your object, and because this is the object, okay, it has a certain it has a certain mass. Okay, it has a certain mass. Okay, this mass in in kg. Okay, it has a certain mass in in kilograms. Okay, it has a certain mass in in kilograms. Okay, it has a certain mass in in kilograms. Okay, so here now the person here, the type of force applying here is simply pushing. Okay, it's a push. Okay, so he's applying a push, okay, a force in this on this object. Okay, so he's applying a force on the object. So you find that as the force is being applied by the human being here, this wheelbarrow starts to move in this direction. Okay, the wheelbarrow will move in same direction as the force. Okay, it will move in the same direction as the as the force. Okay, so you find that as the object is moving like this, okay, so here before everything starts, actually this object together with the person, they will be at rest. Okay, they will be at rest. Okay, and we know what happens when an object is at rest. The initial velocity, which is denoted by u, is equal to 0 meters per second. Okay, so for this object to move, it will gain somewhat acceleration. Okay, it will gain somewhat acceleration. Okay, so you apply a force, the object here starts to move, it gains acceleration, and then it begins to do what? To move. Okay, so linking the three physical quantities here, you have one, force, two, okay, this is acceleration, which is our number 2, and our number 3, which is mass. Okay, so linking these together, okay, we say that the force, okay, force is directly proportional, okay, to the acceleration. Okay, and we know here what remains constant is the mass. So force, it is simply equal to mass times times acceleration. Okay, force is simply equal to mass times the acceleration. Okay, force is equal to mass times the acceleration. Okay, so this is actually what goes on. So this is how this formula can be derived here in just simple terms. Okay, so force is equal to mass times the acceleration. Okay, now the SI units, the SI unit for force, SI unit of force are simply newtons. Okay, SI unit for force are simply newtons. Okay, which is denoted by the capital letter the capital letter N. Okay, denoted by the capital letter N. Okay, so let's have an example. Okay, so in this example, so a man pushes a box of mass 5 kg with an acceleration of 2 meters per second squared, calculate the force applied. Okay, so to just maybe illustrate this, so you have this man pushing a box. So this is the box that is being pushed. Okay, so this box, we're told it is what? It is 5 kg. The box, it is simply 5 kg to move this direction with an acceleration of what? Of 2 meters per second what? Squared. Okay, so we find the force that is being applied. So we're going to say force is equal to mass times acceleration. The mass is 5 kg times acceleration, 2 meters per second squared, and here you get a force of what? 10 newtons. Okay, you get a force of 10 newtons. Okay, so let's quickly just go to something. So we have what we call the resultant force. Okay, so let's look at the resultant force. So under resultant force here, we're going to look at the 3 Newton's laws of motion. Okay, we're going to look at the 3 Newton's laws of motion. Okay, the 3 Newton's laws of what? Of motion. Okay, so now let's look at number 1. Well, let's consider what we call balanced forces. So for balanced forces here, let's say you have an object. Okay, so this object is resting here. Okay, so let's say you have a force here acting this direction and other force acting on the object in this direction. Okay, so if let's say you have this force is 5 newtons and the other force is also 5 what? 5 newtons. Okay, so if you have 2 forces acting on an object and these forces are equal, okay, these forces are what? Are equal in magnitude. Okay, but they're just opposite in direction, but then they're equal in magnitude. So what happens that these forces, they are called balanced forces, and this is because if you find the resultant force, okay, the resultant force here, you're going to get the force on the left, which is 5 newtons, subtract the force on the right, which is 5 newtons, and you get what? 0 newton. Okay, so this simply means that these forces are what? Are balanced. Okay, the forces are balanced and the resultant force is what? 0. Okay, so here we say the resultant force is what? Is 0. Okay, the resultant force here is what? Is 0. So according to Newton's first law of motion, okay, so let's look at Newton's first law of motion. Newton's first law of motion. So according to Newton's first law of motion, it states that for a body that is at rest with balanced forces, or it's in motion with balanced forces, it will continue to remain at rest. Okay, or if it's in motion, it will continue to stay in motion unless an external force acts on it. Okay, that is Newton's what? Newton's first law of what? Of motion. Okay, so 2, let's look at unbalanced forces. Unbalanced forces. So for unbalanced forces, okay, let's consider we have a box resting on a flat surface. So you have a force here, let's say this force is 10 newtons, and you have another force acting here which is 15 newtons. Okay, so as we can see, the forces are not equal, so this simply means the forces are not balanced. Okay, the forces are not balanced. Okay, so now here, this object now, this force is pushing it here, this side, okay, and this other force is pushing it this side. So what will happen here is that at the end of the day, okay, this object here will move, okay, to be pushed this side, okay, to be pushed this side. okay, to be pushed this side. Okay, why is it going to be pushed this side? This is because you have a greater force here that is able to overcome the lesser force that is this side. Okay, so this force to push it this side, okay, to push this force this side. Okay, so here we said the forces are balanced. Okay, so we can simply say here that object remains at rest because the forces are balanced. It won't move either to the right or to the left in this first case, but here the object will move to the left, okay, because we know it has a greater force. Okay, so here we say object moves to the left. The object will move to the left because the greater force, which is 15 Newton force, is pushing it to the left. So the object will move to the left. Okay, now here we need to find the resultant force. Okay, so the resultant force, we say resultant force is simply equal to, so you start with the greater force 15 Newton minus the lesser force, which is 10 Newton. You end up with what? 5 Newton. So 5 Newton is your resultant what? Is your resultant what? Force. Okay, 5 Newton is your resultant what? Force. Okay, 5 Newton is resultant force. So, and this is the force that will make this object to do what? To move. Okay, this is the force that will make this object to move. Okay, so we have a question here. A 20 Newton force and a 60 Newton force are acting on a 200 kg box as shown below. Okay, so find the resultant force and the acceleration. Okay, so you have this scenario here. You have this force here. We call this force 1. We call this force 2. Okay, so both forces are acting on this object. Okay, so the question says find the resultant force and the acceleration. Okay, so solution. Okay, so we're going to say resultant force is simply equal to the bigger force, which is F1 minus F2. Okay, so here F1, that is 60 Newton, minus F2, it is 20 Newton. So the resultant force in this case, it is simply 40 Newton. Okay, this is the resultant what? The resultant force. Okay, so FR resultant what? Force. Okay, so the other part says and the acceleration. Okay, so we know that force is equal to mass times what? Acceleration. Okay, mass times acceleration. So now we found out that the resultant force is 40 Newton. Okay, this is the resultant force, the 40 Newton. So this object now, it's going to move. We know that this force is able to overcome the 20 Newton force and it will push the object this side. So at the end of the day, you end up with something like this. Okay, this object will be pushed to this side. Look at the greater forces this side, so it will push the object this side. Okay, and we've calculated the resultant force to be 40 Newton. Okay, so meaning it will be moved this side. Okay, with a force of 40 Newton. Okay, meaning the resultant force is simply 40 Newton, and that's the force that will push this object this side. Okay, now this object, remember, we're told it is 200 kg. Now I want us to find the acceleration that this force is going to gain. Okay, the acceleration that this force is going to do what? To gain. Okay, so we know here we have force is equals to mass times acceleration. Change the subtotal formula to acceleration. You get acceleration is simply equal to force over mass. Okay, so our force here, you get the resultant force, which is 40 Newton over the mass, which is 200 kg. Okay, you cancel this, you cancel that. There are 1, there are 5. Okay, so you get 1, that's 0, so you get 0.2 meters per second what squared. Okay, so that is the acceleration for this question. So you can see here the forces are not balanced. Okay, so the forces are not balanced. You find the resultant force. Okay, and then we've been able to find also the acceleration being given the mass there. Okay, so I think that's all in this video. Okay, so if you have questions under this topic, please leave a comment on the comment section. Okay, if you need tuitions, you can also leave a comment. I can contact you there